On question 19, in order to have two solutions, we know b squared minus 4ac must be greater than 0. Well, on this particular problem, a is 2, b is negative 3, and c is 5k. So we want to find k, so we're going to go b squared, so negative 3 squared, minus 4, times a, which is 2, times c, which is 5k, must be greater than 0. Well, let's simplify. So that's 9. 4 times 2 is 8, times 5 is 40k. No, 40, not 8. 40k must be greater than 0. Well, I think I'll subtract 9 from both sides. So then we'll get negative 40k is greater than negative 9. Divide both sides by negative 40. K is less than 9 over 40. And there we have it. Notice we had to flip the signs because we divided by a negative. Now on the next ones, if the graph of a related quadratic function doesn't have any x-intercept, that means it has no real solutions. Now, if the graph of the related quadratic function touches but does not cross the axis, it'll have one real solution. If the graph of the related function intersects the axis twice, it will have two real solutions. If both a and b are greater than 0 and c is less than 0, so in other words, I want to do b squared minus 4ac. Okay, and that means we're going to take a positive, because b is positive, and I'm going to square that. But a minus 4 times a, which is going to be a positive, times c, which is going to be a negative. Well, that's going to be a positive plus a positive, isn't it? Circle my positives there. Because a negative times a negative is a positive. So in other words, everything's going to be positive, so my answer is going to be positive, so we're going to have two real solutions. Why can the discriminant be used to confirm? Well, because of the square root. The square root of 0 means that we're only adding 0. We can't really subtract 0. That's one solution. Okay. If I have my square root being positive, we're doing plus or minus a positive. So we're going to get two solutions. And if we take the square root of a negative, well, the square root of a negative is no solution because you can't take the square root of a negative in Algebra 1. And there's your answer.